Hey everyone. So now we are going to be moving into the second derivative test. So pause the video and try these two practice AP problems. So to find the inflection point, we set second derivative equal to 0. So when we do that, we're setting this equal to 0, so we get 0, -1, and 2. I'm going to put that on the number line. So 0, -1, and 2. All of those may not be inflection points though. So at my test point, I'm going to plug in 3. If I plug in 3, I get a positive, a positive, a positive. Plug in 1, I get a negative. If I plug in -1/2, I get a positive. And if I plug in -2, I get a positive. So that -1 is not an inflection point. So it's just 0 and 2. And I could kind of tell that because I knew it wasn't going to change sign because of this square. And then number 2, f of x is x plus sine. Find the smallest positive number at which the function changes concavity. So that's basically asking inflection point, right? So f prime is 1 plus cosine x. F double prime is negative sine x. Negative sine x equals 0 at pi, 0, 2 pi. But it wants a positive number. So my guess is the answer is going to be pi. Let's see, 0 to pi is, sine is positive, but there's a negative in front, so negative, plus, so it would be pi. That's it. All right, the second derivative test. Let f be a function where f prime and f double prime exist on the open interval. Suppose c lies in a to b and is a critical number. So c is a critical number. If the second derivative at c is less than 0, then f of c is a local max. If f double prime of c is greater than 0, f of c is a local minimum. So if the second derivative at that point is less than 0, it's a max. So think of it like this. If we have a max, what's the concavity? That's concave down, right? So it's kind of logical. If we have a minimum, our graph is concave up. So basically that's what it's saying. Now you can use the first derivative test. Let's check the signs on either side, but sometimes this is easier. Okay, so determine where f is concave up and concave down. So we have f prime. This is similar to the do now. 1 plus 2 sine x. F double prime is 2 cosine x. To figure out concavity, set the second derivative equal to 0. So 0 to 2 pi. So cosine equals to 0 at pi over 2. Oops. And 3 pi over 2. So 0 to pi over 2, that is positive, negative, positive. Right? So we're just plugging into cosine. And I literally just think about the graph, right? Cosine is positive till it hits pi over 2, and then negative, and then positive. So this thing is concave up from 0 to pi over 2, and 3 pi over 2 to 2 pi. Sorry, it's messy. And then concave down from pi over 2 to 3 pi over 2. Find any inflection points. Well, we just found them, right? The inflection points are pi over 2 and 3 pi over 2. Use the second derivative test to identify local extrema. So we have to find f prime equaling 0. So when does 1 plus 2 sine x equal 0? So 1 plus 2 sine x equals 0 at sine x equals -1/2. So that is 30 degrees, which is pi over 6. But we are in quadrants. All students take calculus quadrants 3 and quadrants 4. So quadrant 3, that's pi plus, that's 7 pi over 6. And quadrant 4, 2 minus a sixth, 11 pi over 6. All right, so those are my two critical numbers. Now I'm going to plug them into the second derivative. So f double prime of 7 pi over 6. So that's 2 cosine of 7 pi over 6. And we don't actually need the number. We just need to know, is that positive or negative? So this is quadrant 3. Cosine is negative in quadrant 3. So since it's less than 0, that's concave down. That means it's a relative max. So this is a relative max. And then f double prime, less than, that's not less than 0. Yes, less than 0, sorry. My brain stopped working. 11 pi over 6. 2 cosine of 11 pi over 6. That one's greater than 0 because cosine is positive in quadrant 4. So that means we are concave up, so it's a relative min. And I think that's actually easier doing it this way for this problem than trying to figure out positives and negatives on either side of 1 plus 2 sine x. I think that's challenging, right? Okay, what's to the left of 7 pi over 6? What's to the right of 7 pi over 6? I think that's a challenging method. I think with trig functions, it's almost easier to do the second derivative test. All right, so I want you to pause and do this one on your own. All right, determine where f is concave up and concave down. So f prime is 4x cubed plus 4x. F double prime, 12x squared plus 4. Set that equal to 0. Uh-oh. This never equals 0. This never, x squared plus 1 equals 0. So this is always concave up. This is concave up on all real numbers. And it's never concave down. There are no inflection points. Identify local extrema. So f prime equals 0. So 4x cubed plus 4x equals 0. That's the first derivative. Factor. X squared plus 1. So this x squared plus 1 will never equal 0. X equals 0 is our critical number. F double prime of 0 is 12 0 squared plus 4, which is greater than 0. So that is concave up, so it's a relative min. That's it. Next page. All right, again, try it on your own. A little harder. All right, determine where f is concave up and concave down. Ooh, this looks a little gross, doesn't it? All right, f prime equals 2 x plus 1 times e to the negative x. And then that's the derivative of the first times the second. Derivative of the second. So it's negative x plus 1 squared e to the negative x. So that's the first derivative. So you know what? I'm actually going to, since C asks to test the local extrema, let's solve that. So 0 equals, I'm going to pull out, I dropped my squared, x plus 1 and e to the negative x. And I'm left with 2 minus x plus 1. set that equal to 0. This is 1 minus x. So our local extrema is x equals 1 and x equals negative 1. Because e will never equal 0. Alright, so now we need to take the derivative again. I'm trying to think, what's the easiest way? Maybe the easiest way to take the derivative here is probably to use this. So we have e to the negative x times x plus 1 times 1 minus x. That's actually a nice, that's 1 minus x squared. Alright, I'm going to do a product rule on that. I think it's going to be easier. So f double prime equals negative e to the negative x, 1 minus x squared, minus 2x e to the negative x. Set that equal to 0, pull out the e to the negative x, and pull out negative 1 minus x squared plus 2x. That is negative x squared plus 2x plus 1. Negative x squared minus 2x minus 1. That's not factorable. Ooh! We gotta do the quadratic formula. That's terrible. Ugh. I'm gonna complete the square. We get 1 plus or minus root 2. That's gross. Alright, so 1 plus root 2, 1 minus root 2. Alright, so let's see. If we plug in 0, we get a negative. We plug in 5, we get a positive. Plug in negative 5, we get a positive. Ugh, that was a terrible problem. Alright, so this is concave up, negative infinity to 1 minus root 2, and 1 plus root 2 to infinity. Concave down, 1 minus root 2 to 1 plus root 2. And these are the inflection. Those are your IPs. Alright, so now we have to plug those, the 1 and the negative 1, into that the second derivative. So f double prime is e to the negative x times x squared minus 2x minus 1. So let's see. F double prime of 1, that's e to the negative 1, which is always positive. And then 1 times negative 2, so that's less than 0. F double prime of negative 1, that's e to the first. And we get 1 plus 2 minus 1. That's greater than 0. So x equals 1 is less than 0. That's concave down, so that's a relative max. F double prime of negative 1 is greater than 0. That's concave up. That's a relative min. That's a gross problem, but it's something that you should be able to do. And it's really just it's solving for those inflection points, which is difficult. All right, last one. This is a practice AP problem. Find the x-coordinates of the relative max and min. Justify your answer. So I want you to pause and try it. X-coordinates of the relative max and min. So let's see. Where is f prime equal to 0? F prime equals 0 at x equals negative 1 x equals 4. Are either of those max, min, or neither? So x equals -1 changes from negative to positive. Also, f double prime of 1 is positive. So if we wanted to use the second derivative test, f double prime of -1 is greater than 0, and f prime of -1 equals 0. So x equals -1 is a relative, it's concave up, relative min of f. X equals 4, on the other hand, is neither, because it does not change sign, right? Positive, positive. X equals 4 is neither a max or min, because it doesn't change sign. And then also, notice the second derivative is 0, so that actually gives us no information. You can't say because the second derivative of 4 is 0, that just tells you that you're not allowed to use the second derivative test for that point. How about points of inflection? So points of inflection where the second derivative equals 0 at, let's see, x equals 2 and x equals 4. They are both inflection points because they change sign, right? At 2, it goes from positive to negative. At 4, we go from negative to positive. These are both inflection points because f double prime equals 0 and changes from positive to negative or vice versa. And f double prime equals 0 and f double prime changes. Inflection points, yep. Just checking, you gotta watch your. All right, there's your homework. Practice. Have a great day.